All right, last section for chapter 2 is over geometric proof. So this is where the proofs start to get a little more difficult. The objectives are to write two-column proofs and prove geometric theorems by using the deductive reasoning. There's your vocab. So example 1, let's just start with some examples. We are going to write a justification for each step. Every number, 1, 2, 3, and 4, will have a justification. So I'm going to go ahead and draw in a little table, and this is what our two-column proofs are going to look like. So we will have our steps over here and our reasons over here. And as I said in the last section, every time that you put up here, this is always going to be given. You always put your given information first. So write a justification for each step, given that angle A and angle B are supplementary and measure of angle A equals 45. So they give us this statement and these two diagrams. Write a justification for each step, given that angle A and angle B are supplementary. So first off, what we want to do is kind of just think through it ourselves, what we're going to be doing. Angle A and B are supplementary, so those must equal 180. That's just the rule of supplementary. And then if angle A is 45 and they're supplementary, I can somehow find angle B. So let's just think this through step by step. Again, first we write given. Now they write measurement of angle A plus the measurement of angle B equals 180. Well, that's what we just said is the definition of supplementary angles. So we're just going to write in definition of supplementary angles. Totally fine if you abbreviate. Now, to go from this line to this line, this was given. This is just a math property that we know. We know that A and B equal 180 because of these are supplementary. Now, how do I get from here to there? I went from 2 to 3. I have angle A and angle B equal 180, and now I have no A, but I still have my B and my 180. Well, somewhere up above, I have to be okay with this. So they tell me right here, A is 45, and so now they've taken away this A and they put in a 45. Whenever you do that, that's called substitution. Okay, now we have to get from this line to this line. We have to show how they got from here to there. How do we get from a 45 and a B on the left side and 180 on the right side to only B on the left side and a 135 on the right side? Well, to do that, they did subtraction property of equality. That's it. Okay, a theorem is your first buzzword, is a statement that you can prove. Once you have proven a theorem, you can use it in your later on proofs. So this is the first linear pair theorem you need to have written down. A linear pair theorem, if two angles form a linear pair, then they are supplementary. So if I drew these two angles, angles 1 and 2, because they are linear, they are also supplementary. So if they form that T, the T angles, then they're supplementary. So if they form the T, they are supplementary. What supplementary means they're 180. So that's going to be helpful when we start to prove things. So if I have linear pairs, I can set them equal to 180. Okay, next theorem, congruent supplement theorems. This is kind of like the transitive property. If 1 is congruent, or if 1 and 2 are supplementary and 2 and 3 are supplementary, then 1 and 3 are supplementary. We'll see that later on in a proof. So this is saying if angle 1 equals 25, let's just, 25, and angle 2 equals 155, those are supplementary. If angle 2 still equals 155 and angle 3 equals 25, it's kind of like you cross these out. So if angle 2 is supplementary to both of these, then you know that those are equal. A geometric proof begins with given and prove statements. So they are going to give you something that's given and something that you have to prove, which restate the hypothesis and conclusion of the conjecture. So in a two-column proof, your buzzword is two-column proof. Second buzzword is two-column proof. You list the steps of the proof in the left column Then you write the matching reason for each step in the right column. That's why in that last example, or I guess the first example, example 1, I drew that table. That was a 2-column proof. So I wrote all my steps, I did all the math on the left, and then I wrote all the reasons on the right. All right, so example 2, completing a 2-column proof. Fill in the blanks to complete the 2-column proof. So they're given the segment XY. We need to prove that segment XY is congruent to segment XY. For chapter 2, you're going to be given either a rotating kind of one versus the other, or you're going to be given all of the right side or all of the left side. So let's just fill in what we know. The given, it must be this because that's the only thing that's given. That's it. All right, and now we have to say what's the reflexive property. So XY is equal to XY because of the reflexive. And I believe that this is just supposed to be XY. That's not a segment XY. So down here then, we would just write XY, not the segment. So XY is given. XY equals XY is the reflexive. So now we write the segment is congruent to segment XY because of the definition of congruent segments. This is the confusing part. When you can't just jump to conclusion that says they're equal, so the figures are equal. You have to say the definition of congruent segments, and we'll go through that in class. So before you start writing a proof, you should plan out your logic. That's kind of what we did with the first example. We knew that A and B were supplementary. We knew that A was 45, so somehow we were able to subtract 45 and 180, and we got the 135. So we kind of thought it out before we did it. That's going to be helpful for you as you go along through these. Sometimes you'll be given a plan for a more challenging proof. This plan will detail the major steps of the proof for you. All right, your third and final buzzword is right angle congruent theorem. That just tells you all right angles are congruent. If I gave you the right angle in the corner of the room, that's going to be congruent to the other right angle in the other corner of the room. All right angles are congruent because a right angle is only an angle that is only 90 degrees. A right angle is only 90 degrees, so since all right angles are all 90 degrees, they're all congruent. Congruent complements theorem. This is the same thing with the congruent supplement theorem. If two angles are complementary to the same angle, then the two angles are congruent. So if 1 and 2 are complementary and 2 and 3 are complementary, then that must mean 1 and 3 are congruent. All right, so if a diagram for a proof is not provided, draw your own and mark the given information on it, but do not mark the information in the proof statement on it. So sometimes they will just write out what they're going to tell you, and you have to draw an example to help you through it. Okay, so use the given plan to write a 2-column proof in one case of congruent complements theorem. So given angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, prove angle 1 is congruent to angle 3. So again, they are going to give you the plan, and then they want you to fulfill the plan. The measures of complementary angles add to 90 degrees by definition. We're talking through the plan now. We're going to use substitution to show that the sums of both pairs are equal. Then we're going to use subtraction property and definition of congruent angles to conclude that angle 1 is congruent to angle 3. So let's do that. All right, so this is totally wrong right here. This should stay the steps, and these are the reasons. So we've got all our reasons down here and all our steps over here, so we have to fill those in. So back from the previous slide, we know that 1 and 2 are complementary, and angle 2 and angle 3 are complementary. That was given to us in the last little bit of video. So definition of complementary angles, that's what they said, that we're going to add these up to equal 90. So measure of angle 1 plus measure of angle 2 equals 90. Same with the other ones. Plus measure of angle 3 equals 90. That's the definition of complementary angles. So anytime I see this, I can substitute anything in for these. Angles 1 and 2 equal 90, 2 and 3 equal 90. So because these both equal 90, I can put 90 in, I can put 2 and 3 in for 90. because I've said that these are equal. So now I'm going to write measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3 by substitution. So I've subbed in the fact that 2 plus 3 equals 90 into this 90. Now I have to say, before I take things away, I'm going to subtract these. I have to say what they're equal to. Measure of angle 2 equals measure of angle 2. That's the reflexive property. Now, by the subtraction property, I can take it away from this first line. So I'm taking 2 away from this side and 2 away from that side. That's the substitution property of equality. When I do that, they went ahead and simplified it. I've got the measure of angle 1 equals the measure of angle 3. Now to get back to my congruent, I just say angle 1 is congruent to angle 3, and that reason is because of the definition of congruent angles. That is it for this video. We will go through a lot of these in class. I know I went through that one quickly. The geometric proofs will be better off done in class the more that we do in class. So I did want one video for your notes, though, or one example for your notes.